We will be starting the webinar soon, requesting all the participants to settle down. It will take us, we will start in a minute. We'll just start waiting for 1 or 2 key delegates to join in, and then we will start the session. So let's start. So a very warm good afternoon to all the people who have joined in for this exclusive workshop, and a special warm welcome to people from the Bangalore Water Supply and Sewerage Board. Smart Water and Waste World, one of India's leading media and content platform for the water and waste industry, has been conducting these high-level stakeholder engagements for the last 1 year. The intention of these platforms is for knowledge sharing between utilities, and the idea is that if we can get global experts and global utilities to share their experience, their knowledge with Indian utilities, it's a wonderful platform for everybody where they can learn from each other. We have been doing this engagement platforms. We have done this with MCGM Mumbai, we have done Agra, we have done Indore, Nagpur, we have done Pimpri Chinchwad, and today we are doing it with Bangalore Water Supply and Sewerage Board. We have a senior level team from Bangalore Water Supply and Sewerage Board, and it's my pleasure to have Sanmit Ahuja representing Sea Ganga and Paul Fountain from Thames Water, who's going to talk about the journey that they have had managing sludge for them at Thames Water. The format we are going to use today is that we are going to start with Paul, who is going to talk about the technology and the implementations at Thames Water. This is then going to be followed by Sanmit Ahuja, who's going to talk about the economics of sludge management, the kind of research and work that's happened in Delhi, and their views around how, sludge management can become economically viable. And then we open it up for discussions between the various stakeholders, that is Paul, Sanmit, and the Bangalore Water Supply and Sewerage team, that they might have certain questions, and this could be an open discussion. So without taking too much time, I would now like to invite Paul Fountain from Thames Water to do his presentation. Over to you, Paul.
Thank you very much. I'll just share my screen here, and hopefully you can all see that, and that works for you. Can you see the screen?
Yes, we can.
Very good. Thank you very much. And thank you from not quite so warm a part of the world, from England, but it's good to be with you and to be able to share some of our experiences with you. I am here representing Thames Water, who are the largest water and sewage treatment company in the United Kingdom. These are some of the things we're going to be talking about. Really looking at what to do with sludge, how opportunities for digestion, and what are some of the options available to us. We are in the United Kingdom, and a little bit about the United Kingdom. So the United Kingdom was divided up into river basins, effectively. And so Thames Water are this river basin down here, which is the London region. All of the water that flows into the Thames River is in our area. There are 13 areas around the United Kingdom. We serve about 15 million customers in both water supply and sewage treatment, like you do. We have 350 sewage treatment plants. Many of them are very small. And the very small ones then send their biosolids, their sludge, into 30 sludge treatment centers where we treat all and process all of the sludge. We treat about just over 1,000 dry tons of sludge a day, most of it going to incineration, but some of it going to, most of it going to digestion, but a small amount of it going to incineration as well. And last year, we generated 313 gigawatt hours of electricity, plus useful heat. This year, it's more like 350 gigawatt hours. We're the largest producer of renewable energy in the London area. Most of our treatment plants, coarse green inlet works, grit removal fine screens, followed by primary tanks. We think primary tanks are a very good way to do things because the quality of primary sludge is much better than secondary sludge. On smaller treatment works, we would follow that with trickling filters. On large treatment works, we follow that with activated sludge. This is a picture of Mogden, which is our second largest sewage treatment plant. And then we generally follow that by anaerobic digestion and then tertiary treatment where it's required. Not many sites have tertiary treatment, but where it is specific, then we do tertiary treatment. So a little bit about our sludge treatment concept, how we manage sludge sites. So we will have a series of small treatment works that will send their sludge into a dewatering center. They will send it as liquid sludge, tanker it in into the dewatering center. From there, it's dewatered and is sent as cake to a centralized sludge treatment center. So out here, you just have the dewatering, and then in here, you have the sludge treatment. And there may be multiple of these around that are sending in cake, but you can also have liquid coming in from the more local sites. Transporting sludge is a very expensive operation. So you want to reduce the amount of water in it so that you can transport it more economically. And then the digested cake, the treated cake, we recycle the majority of it. We recycle back to farmers' fields, not exclusively. We'll talk about that in a little while. So here, all of the very small dots are our sludge, our satellite sites, and then the triangles are the dewatering centers, and then the red dots. So they're distributed all over. This is the London area where we have some particularly large digestion sites, and then these are the ones spread through the rest of the provinces. So we have a whole network of sludge treatment. And this shows some of the routing. This is not the whole of the area. This is part of the area where the liquid sludge is coming in the red lines. The purple sludge is going in as cake to centers. So for instance here, liquid sludge is coming into Whitney, which then goes into Oxford and is treated in Oxford before recycling back out to farmers' fields. So at a sludge treatment center, Basingstoke is our newest sludge treatment center. We have the facility for liquid sludge coming in from the area. We have processing for the indigenous sludge from the site. All of that then feeds pre-THP dewatering. We have a cake silo where our indigenous cake, the liquid imports are all dewatered and go into there, but we also have a cake import facility over here where trucks can bring cake in, where it is processed in THP and thermal hydrolysis. We pressure cooker the sludge so that it digests better and produces more gas. The digesters, you'll see in a minute, they're just behind me. So here is the sludge treatment center. This is the main sewage treatment plant, the inlet, the primary tanks, the activated sludge plant, the final tanks. And then following digestion, everything is sent over for digestion. These three are the digesters. Then we have a dewatering building, and a liquor treatment plant before the liquors are sent back to the treatment works. Indigenous sludge is about 14 ton a day. The liquid imports are about 5 ton dry solids per day, and imported cake, the majority is coming in as cake, is about 33 ton a day, giving us a total just over 50 ton a day. This is not at all one of our larger sites, but it is a new site and quite well laid out, so it makes a very good example. As we zoom in, you can see here's our liquid imports coming in. These are the pre-THP dewatering belts going in. This is cake import coming in, THP, and then our 3 digesters. This is for storing the biogas, which is then burned in the engines to produce electricity. From Basingstoke, we produce all of our own electricity, plus we export electricity to the network. And then the digested sludge is dewatered over here, and this is our liquor treatment plant. This is it, just highlighting some of the detail that we've already talked about for you. This is the final product. We are very proud of our final product. Our aspiration is to make the best quality fertilizer that we can, that farmers will like. And farmers, while they have access to chemical fertilizers, they appreciate, excuse me, they appreciate the organic content that we can provide them. It makes an extremely good quality fertilizer, and having been through advanced digestion, it's very low odor and makes a very stackable product. And we have farmers fighting for this and farmers paying money for this, where they wouldn't pay money for our traditional products, they will pay money for this product. A few notes about dewatering centers. Rag is the enemy of sludge treatment. It is a real problem, and it's useless it's very difficult to treat it once it gets to site. So what you really want to do is make sure that all sludge is screened before it arrives on site. Well, cake needs to be screened before it arrives on site. Liquid sludges must be screened as soon as they arrive on site, because you don't want rag shutting down your whole system. When you're looking at a sludge center, you need to think about the effluent stream. Typically, an effluent stream is sized for its sludge stream, but when you make it an import center, you have a lot more liquors going back to the works. So you just need to think about where you've got the capacity to do that. It makes no sense to build a large sludge treatment center if you don't have the effluent capacity to go with it. So you need to think about that one. You also need to think about location and overly centralizing. In the UK, the value of what we pay to buy electricity is very different than what we sell electricity for. So the electricity we use on site has a value of about 15 pence a kilowatt to us. The electricity we sell is only worth about 4 pence a kilowatt. So we want to centralize enough to generate all our own power, but not to export power. Or if we're going to make biomethane, which increasingly now we're doing, we want to make sure that a sludge center, we would only do it at a sludge center that is near a gas main where we can put it into there. Or if we're going to use it for vehicle fuel, that it's near a transport hub or a bus hub where we can easily provide that fuel to those users. Some centralizing is good, but don't over centralize, has been our experience. The other thing as an operator, so the things that matter to me as an operator, my system must be robust. We have 20 water treatment plants. We probably 20 large ones. We probably have 50 in total water treatment plants around. And when one of them breaks, I can take a tanker from another site to provide water for those customers. You can put a tanker in the middle of the street, people come, they get their water, they go home. With sewage treatment, you can't do that. And the importance of having reliability of a sewage treatment plant absolutely matters. People do not stop contributing to your sewer system. So you must have a robust and reliable system. But you also want it to be cost effective. And the truth is, for many years, we didn't even look at cost effective. But the more we look at cost effective, the more we have begun to realize that using smarter ways of doing things, you can significantly change your cost of treatment. And we'll talk about that in a little while, because getting the economics right does matter. So let's look at cost of treatment. I won't go into all of the detail. I'm happy to talk about it, but these are real numbers from our treatment work. So originally, we just took digested sludge liquid to land, and it cost us a fortune. So we then started dewatering the sludge and taking it to landfill, just to wherever we could. And that also cost us a fortune. So we then started looking at other technologies. We started doing lime stabilization. That was cheaper, but it still cost us a lot of money. We then have looked at digestion. Now, in digestion, I have costs, but I also have incomes from the biogas and the electricity I produce. And what matters is this red line here, the net to me, the balance of my costs and my incomes. And the summary of this, without getting into lots of details, is the more effectively I digest, the better my cost of treatment. And where it used to cost us a lot of money to process our sludge, we're almost to a point where we're breaking even on the sludge treatment side, not on the sewer treatment and the networks, but on the sludge treatment side, we're at about a break even where our incomes balance our costs. And that is a really important aspect. We also have incineration. And while incineration offers some wonderful alternatives, it is very expensive. Our history is that it costs, it's our most expensive technology. And at the moment, these figures are for incineration alone, but what we are finding, and we'll talk about in a minute, is combining digestion with incineration is a far more cost-effective way of processing sludge. Sludge is a fantastic resource. It has organics, it has nutrients, it has phosphorus and potassium, and let's recognize those resources and make sure we're managing and using those resources effectively. But the point of this is that doing it smart makes a huge difference and very significant to our overall costs. Now, what makes that work better? Well, it's all about driving to a higher degree of digestion. Digestion effectively is turning what would have been a waste into an income, and what would have been a cost of transporting it out to farmers' fields, but making it into an income. And that lowers my costs and raises my income at the same time. So the more I can digest, the better my economics, but the better everything works, as we'll begin to see. So historically, we have done conventional digestion. Increasingly, we are doing advanced digestion or thermal hydrolysis. You can have copies of these presentations. The purpose is not to teach you everything, but to show you some of the principles. In conventional digestion, you get some digestion, but there's primary sludge digests very well. Activated sludge hardly digests at all. But by the time I go to thermal hydrolysis and I break down these cell structures, there's a slight improvement in the primary, but there's a massive improvement in the activated sludge digestibility, and moves me a step forward in digestion. And the more it digests, the more gas it produces. But it also means I can load my digesters much harder. So his conventional digestion, we loaded about 2.5 kilos of organic matter per meter cube per day. Advanced digestion, we can load at 6 or 7. Much better. But also, we get much better dewaterability. My final product going to land has less water in it, so therefore it costs less to transport. And you can see a big step up, which is what's pushed us to going to advanced digestion. And that's what's pushed us from here, up to here, up to here, up to here, and giving us better economics in our digestion process. Now, one of the big things that people will talk about is odor. And in my view, it's a similar process to oil refinery. So in an oil refinery, I have my heavies and my mediums and my lights. So these are your tars and your heavy fuels. Up here is your petroleums and your jet fuels. The same with organics. These organics, the heavy organics, they don't smell at all. It's these very light volatile organics that are odorous, which is why your inlet work smells. So what I want to do is make sure I'm treating all of these. And poor digestion only treats the top end. The more you digest, and by the time you get to advanced digestion, you've consumed all of these organics, and you're only left with these very heavy, non-smelly ones that are not a problem. You still have organics to recycle to land, but they're not your heavy, they're not your light odorous organics to go to land. The same is absolutely true with dewatering. It's these organics that don't dewater well. Those organics dewater very well. And this, again, based on data from what we found, initially sludge digests very well. As soon as you put it into a digester, it digests very poorly. But the longer or the more you digest it, because it's not just about time, it's about degree of digestion, the better it dewaters. And so being able to push up to this end of getting really good dry solids means it's more stackable, means the farmers like it better, and I decrease my transport costs. And this is what I end up with. So the picture you saw earlier was from Basingstoke. This is from Oxford, a very high quality fertilizer that the farmers really, really like. Here's the Basingstoke picture again. Very similar product, great favorite of the farmers. And I also end up with a clean filtrate going back to the works that puts less load on my effluent plant. A note on stackability, because particularly for our urban areas and because of spreading seasons for farmers, we can't get it out all the time. Conventional digestion doesn't stack as well, whereas advanced digestion, I can stack to 2.5 to 4 meters high, which means I can stack in a much smaller footprint to store the cake before it can go to land. When I then start looking at storage, so this is just a simple spreadsheet looking at 100 ton a day and how much storage area I would need. Very poor digestion, I could need up to 540 meters squared per day. Very good digestion, I could need 34. That's massive when you're thinking about the capital that you're going to need to build your area, which is why we want to push for as advanced digestion as possible, that it will store in a smaller area as possible. These are just summarizing some of the numbers I've given you: organic loading rates, biogas production rates, how much electricity I would create per ton dry solid, the dry solids of the products. This conventional is acceptable. Advanced digestion with belt press is preferred. Advanced digestion with high dry solids, the farmers will pay good money for that. And here, in terms of transport to land, for every ton dry solid that comes in, I have 0.15 trucks going out, 0.808 trucks going out, or zero. So a third less trucks transporting to farmers' fields than from this technology, all hinging around how well I digested in the first place. And this is what shifts our economics and our end product. So all of these factors matter to produce a good quality product that will go to farmers' fields. In thinking about farmers' fields in the UK, we are regulated. So there's untreated sludges, which we can't do anything with anymore. There's conventionally treated sludges that can go to some crops, but not others. Or there is enhanced treated advanced digestion sludges, which we can put on all different crops. So that opens up the possibilities for us for a market. So how have we developed over time? Well, this is where we were 10 years ago. Still a similar amount of sludge, but very little. The green here is advanced digestion. The yellow is conventional digestion. We had a lot of incineration, quite a bit going to liming and going to composting. And then this is now 5 or 6 years ago that had started to shift. And by now, the majority of our sludge is going to advanced digestion, still a fair bit to thermal hydrolysis, a small amount going to incineration, and almost nothing going to liming and nothing going to composting anymore. Worldwide, these are all the advanced digestion sites around the world by their size. Washington, DC, I'm told there's a lot of poo in Washington, so but sites, and when you look at the blue ones, these are all of the sites that are in the UK, and if I do the red, that's all of the sites that are in Thames Water. So Thames Water is one of the big players in this market because we've understood the economics of it, and that's what's driving us to go to advanced digestion. This is the same graph, but showing over time the capacity of the different water companies. So this is the capacity of Thames. This is the capacity of all of the other water companies in the UK combined, and all of the companies in the world. So you can see that we're a quarter of the world's advanced digestion process. And it's what is enabling us to be robust, reliable, and cost effective. Now, a few comments about various technologies. We have tried all of these different technologies. Because we have so much sludge and we have so many sewage treatment plants, we've been able to try a lot of it. We've tried drying and composting, different kinds of composting, chemical stable, we've tried all of this. And what we come back to is the best way to go is anaerobic digestion, and the best way to go is advanced digestion, effectively thermal hydrolysis, looking at different combinations. And what I would say is historically, when we built our incinerators 20 years ago, we thought there was a trade-off. You either chose to go incineration or you chose to go digestion. What we would now say is that we would always go to digestion first, and then go to, if we can go to land, we will, because we believe that it's good for those organics to go back to the land. But if we can't go to land, we will then incinerate, but we will incinerate digested sludge, not raw sludge, because that's a much better way to recover energy and to be cost effective. If I can just tell you a little bit of that story. This is one of our incinerators. We have 2 incinerators in London. This is looking at 1 ton of sludge coming to be incinerated. Now, if I put it as liquid sludge, I have a huge volume. I'll get my 750 kilowatts per ton dry solid, but I have a huge volume. And most of that is liquid. And all of that liquid has to be evaporated, which consumes a huge amount of energy. If I can make it cake and get rid of a lot of that liquid, I can get it up to 25% dry solids. That's very helpful because I've dropped now to 3 meters cube of sludge per 3 meters cube of liquid per ton of sludge. But that's still a lot of liquid. If I digest it first, I don't do anything else, I just do conventional digestion. Now the thing shifts, and instead of 3 meters cube of water, I only have 2.5 meters cube of water. So my incinerator works better. And now if I go to advanced digestion, I drop to 1.1, I drop to 0.8 meters cube of water per ton dry solid. And the whole incineration process starts singing much better. And I get energy production out on my digestion plant. I get energy production on my incinerator, and I effectively double the amount of electricity I produce. And for Thames, this is our future. This is where we're going. Where we can go back to land, we will, because that's important for society. But where we can't, and we are required to incinerate, or we need to incinerate, or if we were to have contaminated sludge. Now in the UK, we don't have contaminated sludges, but if there were an application where we did have I would always recommend digesting first and then incinerating, simply because there's less water associated with that sludge. So the whole process works more efficiently. Here's an example. This is raw sludge, its calorific value, the amount of moisture in it, because all that moisture has to be evaporated off. So this is the heat required to evaporate, and this is the net left to the incinerator. When I bring in digested sludge, it has less calorific value, but because it's much drier, then I end up with the same net. But actually, historically, we've found not only is it drier, but it burns better. So we get a significant increase in our production from that cake. So I got benefit out there and I get benefit here, and the whole thing just works an awful lot better. One other comment for you, just to share our learning. So our incinerators are fluidized bed incinerators. They work well. They're expensive, but they work well. We have sludge and air coming in. We have to recycle a bit of heat back, which gives us our thermal input that comes up through a fluidized bed. We balance with gas to keep the temperatures controlled. That comes in. But because the air leaving also has to have some heat in it, it has to be at least above 105 degrees C. I lose a lot of my heat to my airstream. So some of my heat is going back to my recycle, some of my heat is going to my airstream, and it's not very efficient in what goes to generation. It's efficient in thermally combusting the sludge, but it's not efficient in generating electricity. So therefore, we're looking at going to gasification and pyrolysis, where we call it advanced energy recovery. So because the cake coming out of THP is already so dry, we can use low temperature belt dryers, and we can then go to pyrolysis, which unlocks even more energy because it's more efficient, because it doesn't have the air treatment process that a fluidized bed incinerator has. It uses combustion without air. Then we get much more electrical efficiency out of it, much more energy production out of it. And we have one of these plants has been built in East London at Crossness, and it will be going into production shortly. So that's the end of my presentation. Thank you. And I pass it back to others, and we'll take questions a bit later.
Thank you, Paul, for sharing this wonderful presentation. As I said, the intention of this platform is for knowledge share between utilities. So it's great to see the work that's happened at Thames. I would now like to invite Sanmit Ahuja from Independent Board Member Expert from Sea Ganga to share his views before we go and open it up to discussions. Just a point, if anybody wants to ask any questions, they could raise their hand or put it in the Q&A box, and I will ask my technical person to allow you to speak so that you can ask the question directly. So first, over to you, Sanmit.
Thank you, Kailash, and thanks to Paul for a very comprehensive presentation. So my name is Sanmit Ahuja. I am a board member or expert member, as we call it in India, at Sea Ganga, which is a think tank and innovation agency under the Ministry of Jal Shakti and operated under the aegis of the National Mission for Clean Ganga. Sea Ganga is a collective of 40 plus institutions of national eminence, and it is headquartered and led by IIT Kanpur. Its role is to develop the master plan for the Ganga River Basin, to continuously evolve it, to develop data and information platforms, to bring new innovations to market. And innovations is not just technology, it's also in policy innovations, it's also in financial modeling. So when we looked at sludge, of course, as Paul mentioned, it's a problem for a lot of the countries, but in India, it's even more peculiar because we never really integrated sludge management as part of our policy framework. And for most part, sludge was either diverted to landfills, dumped into rivers, or thrown untreated onto the fields. But increasingly, as the rate of urbanization is accelerating, increasingly, sludge management is becoming a big problem for municipalities and urban bodies. So when we started to look at sludge very specifically, we thought first it'll be good to understand best practices from around the world. And we entered into a collaboration with NIBIO, which is the Norwegian Institute of Bioeconomy Research in Norway, with who we did an extensive research and exercise on what is really happening with sludge management globally. And Paul has given you a good glimpse of that. We'll be releasing the results or the report in the next week or so. I wasn't planning on showing some slides, but I thought just to kind of bring some perspective, I will try and do that. So if Kailash, your team can allow me to show the slides.
Yes,
Ram, can you give screen sharing, please?
it's done.
Okay. I'm not seeing the option.
You can click on share screen at the bottom.
There's a green, there should be a
No, I've
green
done
button
that.
at the bottom of your screen that says screen share.
I've done that, but it doesn't then bring up the options of picking up. It's just showing me select your screen or select the whiteboard. Let's see if this works.
Yeah, that worked.
That worked? Okay, good, lovely. So when we looked at the sludge management, ultimately, how do you create the right economic framework? Many cities are kind of confused, as we realized. We've spoken to more than 20 municipalities, large and small, and ultimately the economic drivers are a function of what are we trying to achieve. Paul mentioned that increasingly cost management is becoming a big function. Of course, that is a primary function in India, but managing environmental costs also require internalizing those environmental costs. And we don't yet have a robust framework, economic framework in India to, to manage those environmental costs. The moment we start internalizing, the capital cost of setting up the plant and operating the plant, of course, increases. But who is funding that? Right? If it is being funded largely by the government, then the demand on capital goes through the roof. If it's funded largely through market drivers, so in effect, producing or sustaining the cost through electricity production, gas production, or fertilizer production, then we have to create those market fundamentals to support sludge management. So this particular slide will kind of give you a good sense of how we are going about and understanding how to deploy sludge management in the country. There's a lot of, I would say, a myth that fertilizer production alone can subsidize the cost of the sludge management, and I think that will remain a myth. It is not going to be the case in India. It may be the case in other countries. I think it's the energy and land where you get the maximum bang for the buck. Energy, of course, is in form of electricity or bio-CNG. The electricity tariffs in India would not support. There is an electricity tariff that would support if you're exporting to the grid. But if you are using for your internal consumption, then of course those benefits can be realized. Bio-CNG, of course, is a very different kettle. And I think right now the environment is very, very conducive for bio-CNG production in India, because there is an offtake price offered by the government under the Satat scheme, or other commercial buyers who would procure the gas readily from you. This can be supplemented by agriculture, but some of our discussion, not some, in fact, most of our discussions have led to a concern from the farmer community that either the cost of fertilizer has to be subsidized by the government, where most of the fertilizer is subsidized by the government. So why would the farmers pay more for a particular subsidized fertilizer, even if that is green? So that creates one sort of problem set. The other problem is the fear factor that if certain heavy metals and other contaminants sneak through, then they would get into the food chain. Of course, it varies from different parts of the countries. Cities where there is industrial SME industrial practices going on, where we know for a fact that certain contaminants will enter your sewage stream, then of course it is a cause of concern. But at the moment, what we realize that such practices are highly localized in certain areas. For instance, in Kanpur, you will see traces of chromium because of the tannery sector, or in Delhi, there's a lot of SMEs. And they would be dumping their industrial effluents into the sewage network. So it is a headache for wastewater treatment facilities to both assess and address the heavy metals or other contaminants that are coming into your wastewater, and as a result, they will propagate through to your sludges. So that's the concern the farming community has by and large. Land, of course, is a very, very important factor, but how do you translate savings on land to a net economic benefit? That economic benefit has to be transferred and monetized in a certain manner. In many of our projects and tenders that come out, we don't particularly incentivize land saving. So economic instrument is required. The other issues that urban local bodies have is their urban setup, how congested they are, how far, if you are going to go for land application, how far is the farming community from the urban centers. And because cost of transportation will become quite an issue, how if you're moving towards energy, and particularly on biogas generation, then who are the off-takers in the vicinity? And then finally, the quality norms, whether you're going for Class A or not, is a question mark that all the regulators are trying to answer at the moment. But but ultimately, it's the economic drivers, which is driven by what are we trying to achieve, will deliver that answer. If we want 100% wastewater treatment and zero footprint, then we'll have to go for a combination of all of these processes, and particularly the ones that Paul mentioned. And we should learn from the experiences of major players, utilities such as Thames Water. So when we looked at the economics of sludge treatment, we don't yet have figures. In fact, we are starting a study where we're trying to look at half a dozen major cities of all shapes and sizes, large and small, and developing a sludge master plan for each one of them. And the sludge master plan will depend on the parameters that I showed in the slides before. And once we are able to understand how the city, how much sludge is being generated on a daily basis, at what points it is being generated and collected, how many wastewater treatment centers you already have, and which ones of those could actually act as a centralized sludge management facilities, only then will we be able to come up with an economic framework and a financial framework that what is the cost to set up the plant and what is the cost of operating the plant. The government is not averse to providing what's called a VGF, a viability gap funding. I saw in Paul's slides where he showed the various OPEX costs. And if we move towards advanced treatment where we are digesting better, the operational cost does come down almost to a break-even level. If that is the case, then a viability, a one-off capital investment can be made by the government and in form of a viability gap funding, or even a hybrid annuity model through which most of the projects in the Namami Gange program are being actually funded. So that is the framework that we are starting to study. I'll come to this slide later. The challenge for a lot of the municipalities is, okay, we are producing good quality biosolids for land application. We don't want that to go waste, but how do we, if we leave it, each utility, each municipality to their own devices, then it'll be very, very difficult for them to create a market for good quality biosolids. And if those fertilizers are created to a high standard and high spec, then there is, of course, a case to create a market. Now, there, as I said to you, fertilizers is a highly subsidized industry. So we are also studying at what are the price points at which the offtake becomes viable. Looking also at the transportation and distribution costs. So we are in discussions, advanced discussions with a number of national fertilizer companies to create a large market. So essentially 1 or 2 major national fertilizer companies will collaborate with us and will offtake the fertilizer from different sludge treatment centers across the country. So that hopefully will create market for the fertilizer. And similarly, there is already, if you just swap fertilizer with biogas, there is already a market established for biogas. So we are in advanced discussions with a number of large energy utilities to create the the biogas offtake from various treatment plants. There is also an additional element of fecal sludge in India, where septic tanks and other smaller generation points which are not connected to the grid are also a big cause of wastewater and sludge disposal into our river systems. And the idea is to create a decentralized operating framework where smaller contractors could be made available with advanced transportation vehicles and earmarked decentralized facilities. Could be the collection centers where the sludge would be transported to. And of course, we have to study the economics of it, and each city would have its own dynamics. So there is no one size fits all. Every city will have to understand how they develop their own sludge master plan, and that's a process we are starting now. Finally, on the financing part of it, many utilities, advanced utilities, who are now seriously thinking of developing sludge treatment centers or integrating those in the new STPs that are coming up. We are working on developing a sludge bond, which would finance sludge development. Essentially, there would be at least in the Ganga Basin, but also we are developing with Ministry of other departments, government departments, a facility which would allow or enable various municipalities across the country to pool their sludge treatment projects into a combined vehicle, what I call a pooled risk entity. That would get further credit enhancement through asset backing or government backing, and on the basis of that, we will be able to issue a bond. So municipalities who are serious about sludge management and are currently finding constrained they're finding themselves constrained in able to finance the projects because of lack of funding, can come forward to us, and we will help them in raising finance from capital markets and green investors, both in India and around the world, so they can accelerate their sludge financing. So finally, I think that's about it in my slide. So finally, what I would like to say that there is no one size fits all answer on the financing and economics of sludge. We have to take the setting of each city, the quantum of sludge being produced, the locations where wastewater treatment centers are situated, what's the distance, the proximity to the farming community, the proximity to biogas off-takers, whether it's piping or pumping it into, injecting into the national grid, the city grid, or bottling biogas and supplying to commercial establishments. Each city would have its own set of characteristics. And on the financing side, we would have a number of instruments available, from bonds to green insurance to other credit enhancement instruments. But the economics of sludge is a function of proximity, of technology, of markets, and the urban setting in terms of its size of population and the urban congestion. So, I guess I was able to convey some of the key messages on how Government of India is thinking on managing sludge across the nation. Thank you very much, and back to Kailash.
Thank you, Sanmit. Thanks for sharing this information as to how is the government roadmap, or what is the vision that they have with regards to handling the sludge management problem in India. We have finished with the two sessions, and I would like to now throw it open for a discussion. I have enabled Mr. Rajiv, you are from Bangalore Water Supply and Sewerage Board. I have enabled the, option for you to participate. So in case you want to ask any specific questions that you might have to Paul or to Sanmit, I give the floor to you. Also, if anybody within the audience would like to ask questions, if they raise their hands, I would ask my tech team to allow you to speak so that you can, ask the question directly. Over to you, Mr. Rajiv.
Yeah. Good afternoon, sir. This is with respect to both the presentation from the Thames and from our Indian partner is a wonderful one, in which BWSSB is an organization in which from 20 years back itself, we are taken the initiatives to treat the sewage, and of late by JICA assistant loans, we have carry forward the sludge treatment also. In phase 2, I think by 2012 onwards, most of the sewage treatment plants, we are having sludge treatment, in which power generation is also available in one of the 60 MLD treatment plant, and 90 MLD treatment plant at Belanduramani option is there to generate the power also. So in this way, we are moving inch by inch towards the sludge management in our organization. But really the issue is the managing the sludge only, undigested and digested. Huge scope is there for the improvements, and we would like to have more interaction with Thames or other agencies also. Your hydrolysis process is, thermal hydrolysis process is also wonderful one. And as our Indian partner has suggested, the major thing is the financial aspect in this aspect, because capital investment is very huge, and recovery of the revenue for the investment is the issue now, a bottleneck, wherein all the technology providers, consultants, and government agencies and lawmakers has to sit together and formulate a module as the central government is taken initiatives. In that aspects, we have to try to fit in and make use of the funds available in the government sector, and we would like to put more emphasis on the sludge management in coming days. Thank you.
Sir, would you like to ask any questions to either Sanmit or Paul?
For all, what we are seen is Bangalore is almost generating 150 to 200 tons of sludge on every daily basis, in which most of our treatment plants are centralized treatment plants are there in Bangalore, and very few small capacity decentralized plants are also there. What will be the best model for Bangalore scenario as far as Thames experience is considered? That he has to address. Second one is that Sumit, he has informed us about the sludge bond. It is a very new initiative for us. We would like to have more details on that to understand the concept of sludge bonds and how it will be beneficial to municipalities like BWSSB, wherein we have already taken a lot of initiatives, and we have capital investment capacity to certain extent compared to any other municipalities in the Indian scenario. Thank you, sir.
Paul, you would like to take that question first?
Okay. So just in terms of process, for sludge treatment, for resource recovery, for energy recovery, for nutrient recovery, I would always go with digestion. Anaerobic digestion, autoaerobic digestion. The US likes to use, well, no, the US does use aerobic digestion. I would not. I would go with anaerobic digestion. It's a far more efficient process. And I would do it whether I was going to farmers' fields or whether I was going to go on to gasification or pyrolysis or incineration, but I would always start with digestion, and digestion would be my platform on which I built anything else. And whether that's, so you talked about 100, 150 ton dry solid a day. We have plants that are that size. We have plants that are smaller. We have plants that are bigger, but we would put digestion in for that. Now, I thought Sanmit's presentation about the complexity of different applications. For us, digestion absolutely works because of proximity to farms and fields and so forth. Though I still think that for a wide variety of applications, it's the beginning door. It's what enables you to unlock other things. And I suspect that in a majority of the applications, not all, but the majority, it's your starting point. You may then want to add other bells and whistles on, but it would be your starting point. In terms of finances, one thing I would make clear, the figures I gave you are for the sludge stream. They are not for the effluent plant. They're not for the sewage stream, for the network. They're not. So fundamentally, we are a company paid for by our customers. They pay, though, ironically, not ironically, interesting psychology. We charge people for their water, and we double the charge. So we work out their water bill, and then we charge them the double, but it's all counted as a water bill, not a sewage bill, because psychologically people are ready to pay for water. They find it difficult to pay for sewage. But those revenues then subsidize all of our water supply, our network, our everything else. And what we've historically, they also paid for the sludge stream. We've tried to make our sludge stream financially viable on its own right, so that at least we are paying the costs of our sludge stream. But I also understand, just making some notes here and reflections to what's been said, that we started as a nationalized industry that built most of our infrastructure. Our sewage systems were all built, the networks were all built under a nationalized form of operation. We then privatized, and the private companies took over an existing network. So even though we invest in capital now, it's on the back of a big infrastructure. And I think India's in a different place where you're starting, in many cases, at least from a simpler base or no base at all. And therefore your questions about capital are a much bigger question than they have been for us. Now, I still think it's about doing it smart, it's about doing it well, but it's not going to be self-funding, particularly if you're looking at a network system and a collection system and the effluent stream. You can make it, you can try to make it cost effective, but don't expect it to earn money. It won't earn money. If I look at my colleagues in the organic waste industry, food waste industry, they pay a gate fee for processing sludge. Now you still want to do it as best as you can, as cost effectively as you can, but it's not a money printing machine.
Sanmit, you want to maybe share more?
No, so thank you, Paul. And you've highlighted the very issue that why we cannot just lift and drop models, economic models that are prevalent from around the world onto India. India has to develop its own economic construct. So two parts. You mentioned that there's a cost of water supply to households, and inbuilt into that cost is also the cost of treatment. And that's what I mentioned in my opening sentence, that what are we trying to achieve? If it's environmental protection, then the cost of treatment has to be internalized. If we don't internalize the cost of treatment, we can keep running from pillar to post, and we will not find the answer. Which then brings to the question that how much capital is needed, and how will that capital infrastructure or capital formation be sustained in the O&M. So and that's why each city in India has to come up with its own answer, but it has to be underpinned by a national framework. And so far, we've not internalized the cost of sludge in our wastewater treatment plants, and that's the big pink elephant in the room. So, so if we start doing that, the capital cost increases, and that's where Rajiv, and your question on the sludge bonds comes into play. That in absence of the availability of that capital, we look to capital markets for raising and generating that capital, and there's enough interest out there globally, not just in India but globally, to support green infrastructure. And if we can inbuild or embed resource recovery, and in this case the largest resource will be the energy, the gas production, in my opinion, augmented by the fertilizer, but fertilizer will still be a small component. Yes, there's a question or a comment on the chat room that will save municipalities quite a lot of money, but it has to be seen in the context of are the municipalities buying that fertilizer? Yes, some are, for their upkeep of golf courses and public parks and others, but what is the quantum of fertilizer they are buying, and what's the quantum that can be generated? But is that cost saving enough to sustain the sludge management center? And the answer is going to be no. However, if you inbuild the energy savings, then it's will come somewhere near a break even from an operational standpoint. But then who funds the capex remains the big question, and how do you fund that capex? So either you increase taxes, which is not favored by any urban local body. So ultimately, it has to be funded, in my opinion, by the government. As Paul mentioned, in the UK, it was largely a nationalized industry, and private sector, when it got privatized, it assumed or onboarded pre-built infrastructure. Yes, you have to upkeep that infrastructure, but you inherited that asset on your balance sheet on day one. So I think the governments will have to fund this infrastructure. In the Clean Ganga program, we thought the cost of wastewater or creating a wastewater market would be sufficient for private sector or private capital to come in. We realize that is not the case. Private capital is coming in, but in what's called a hybrid annuity model, where the government is funding the capital formation over 10, 15 years, and then paying the operator also an operation fee. Yes, the operator or contractor funds the projects upfront, but they get the funding eventually, recoup it from the government. So we're very happy to work also with the Sea Ganga, whilst our primary remit is the Ganga Basin, but we do projects across the country, and we're very, very happy to work with the BWSSB and share our knowledge, and maybe also bring you under the remit of the half a dozen cities that we are starting to work on for designing the sludge master plan. And in doing that, we will create a matrix, the complex matrix, and put all sorts of technologies into that matrix to see what the capex and opex is, and then how do you eventually finance that.
So if I can just throw one other question out there. So I've just come back from the European Biosolids Conference, and we were talking about environmental impacts just following Glasgow and the whole, what's happening to the world and the environment. And they were challenging each industry to think about how we can save on emissions and greenhouse gas and so on and so forth. It's all very good and very helpful. It's good to be challenged on that. But at the same time, the government is looking at affecting our spreading, our application of fertilizer, organic fertilizer to land. And they're making it increasingly difficult. So we said, okay, that's great. We can. So I've always had the challenge that we are providing a lot of NPK to the land. And while farmers are willing to pay for it, there was a question what farmers are willing to pay in the UK at the moment. They're paying about £10 per meter cube per wet ton, not per dry ton, but per wet ton. But that's nowhere near the NPK value. So there's a challenge, can we get farmers or can we get the market to recognize the NPK value? But there's a deeper question that if the organics are no longer going to the soil, we'll have to be using chemical fertilizers, which have a massive greenhouse impact, in terms of energy use and everything else. So, but that's where we're starting to get multiple industries together and where society has to say, we value your recovering of energy, we value your recovering of fertilizer, and we're going to therefore fund and enable this to happen. But that's a much wider society question, not just a single industry addressing that question.
I'll just add on top of that, Paul, it's a wider society question for sure. And the challenge for a lot of the municipalities is that the benefits, so let's say the land as a benefit or environment as a benefit, who finances that, right? And the consumer eventually will have to pay for it. And once that cost is diffused to the consumer, it becomes an economically viable set of projects. But in diffusing that cost, you have to bring multiple agencies into the mix, because if it's a benefit to the farmer, then Department of Agriculture gets involved, and we need to create an instrument that cross-subsidizes it, the capturing of the NPK value. If it's land, yes, it's the municipality-owned land, but it's a different department in the municipality that gets involved. So a different balance sheet altogether. So how do we cross-subsidize or cross-monetize it? If it's environment, it's world at large. India doesn't have a carbon price to sustain the deployment of various technologies and formation of projects. Then who funds those? So there are different, the capital savings and the costs and the revenues are coming from a disparate set of groups, and there lies the problem. So someone has to weave all of those together with the same thread, and then a solution will begin to emerge. And that's what we're trying to do in Seaganga.
Thanks, Sanmit. Any other questions that we could have from the audience or from Mr. Rajiv or from the BWSSB team?
Thank you, sir. With respect to carbon credit, okay, for generation of the biogas energy and other things as per the France summit, but it is not really that is not realized, sir, so far. We are trying hard to encash the carbon credit just because we are generating the power through biogas. So these are all the issues will definitely add up a lot of incentives to the work we are going to take in sludge management, sir. Anybody add to this, sir?
Sanmit, maybe you want to take that up?
Yeah, Rajiv, I mean, there is a price of carbon, but the price, India does not have a regulated market where the pricing kind of is at par with the prevailing global pricing at the moment. So UK, Paul, is it what, £50 a ton,
Yeah,
something,
about, just about.
yeah, something about that nature. And in India, you would get probably 10% of that. So, so there again, there lies the challenge. So I think we all have to think outside the box and create a proxy carbon price, and that is driven by or realized through bringing the different agencies together. So where on one side a lot of subsidies are being given to the fertilizer sector, how do you cross subsidize if high quality fertilizer is being formed and or created through the sludge treatment centers, and the savings of municipalities coming through? How do we make sure that that market is created? So the answer is not simple, Rajiv. What's the price of carbon? It's a very deep and a loaded question. We even in UK and Europe, the price of carbon is nowhere near what it should be. But I think the world has started to move towards that. In India at the moment, we'll have to look at finding monies from different parts and bringing it together.
Thanks, Sanmit. I think Mr. Mohan Kumar had a question.
Hi, Kailash, can you hear me?
Yes, sir, I can hear you.
Yeah. I'm. Let me introduce myself. I'm Professor Mohan Kumar from IISc Bangalore. I'm retired professor in water resource engineering, and I head the technical committee for BWSSP. So first of all, I think the presentation by both Ahuja and Paul were fantastic. Very nice presentations, and I think rightly both the speakers pointed out we are really battling out with the sewage in general, and of course biosolids in particular. And I think I also liked what Ahuja was talking about. One size fits all will not happen. And at the same time, we have serious issues about sludge management, especially in bigger cities. Take, for example, Bangalore. A lot of data already, Raju spoke about it. And we really need to bring down our footprint in many of these areas so that our plants will become more efficient in their performance, especially in the land area, when we consider and the energy recovery and things like that. And when you try to look at for example, it also came up, one way in all these things, we are trying to really struggle about how to really take out NP and things like that. The other way around, for agriculture, we require in the different farms with the NGT norms. We are really moving around up and down and struggling between these issues. And all the more the reason, I think what I wanted to say, that's why I came in. Along with BWSSP, my colleague engineers are there. We'll be more than happy to interact with Thames water as well as with Sea Ganga. I'm very closely associated with Professor Vinod Tarek in so many meetings and so many other projects. And most of the things, I think, Ahuja, you also know, though in the government circles, getting the capital costs to build the plants, somehow, though it's difficult, we can always find. But then running it is an issue. And that's where I think if we work out the costing as well as the running the plants in different forms, the capital cost somehow we can find with the state governments, central governments and all that, and make sure we start off. That's what I think Paul was also mentioning. We have this infrastructure. In fact, the other day we were there in Puri looking at 24/7 water supply, which was built with a lot of funding from central government like Amrut scheme, JS, JNNURM or so many other schemes. With small tweaking, they're able to deliver 24/7 drinking water to the whole city. I think such things, I'm sure, has to come here also in many of these wastewater treatment plants, especially in the sludge handling. I think that way, I like both the presentations, and I think there'll be a great opportunity to discuss and take this activity forward, especially in Bangalore, probably in a larger setting, even in Karnataka in different cities. Thank you.
So, Mr. Mohan Kumar, I will share with you Paul's contact details, and I'm sure he would love to interact with you.
Sure.
Give you more information. Paul, we have a question from one of the audiences. The question is, how does sludge treatment schemes differ when sludge is VAS only in comparison to primary plus VAS?
Somebody's trying to wind me up. my pet hatred is activated sludge. A few years ago, there was a celebration because activated sludge had achieved 100 years. And for me, I had a very sad party, because while activated sludge solves an effluent problem, it's a very significant biosolids problem. And while primary sludge costs us nothing to process, it's very easy to process. Activated sludge costs us about 250 pounds a ton to process. It's not the organic matter, it's the bugs that ate the organic matter. And they're very thick coated and they don't like digesting. They don't like dewatering. They require a lot of polymer. So you need to see the synergy between the effluent plant and the sewage treatment plant. I would always design a sewage treatment plant to have primary settlement first and then activated sludge. Whereas some designers like to just make it all activated sludge. And while it's great for the effluent plant, it makes it very difficult. So we need joined up thinking. I would always want to maximize as much primary as possible and as little activated sludge as possible. There is also research being done in how to have anaerobic effluent treatment, secondary treatment, which is making good progress. And I think when that happens, it will be a huge economic change for the whole industry, because anaerobic activated sludge is a completely different beast, and but that's still some years off. So for the moment, we just have to live with it. But activated sludge is not helpful.
I think Mr. Berger wanted to ask a question to Sanmit. So, Mr. Berger, I have given you the rights to speak in case you want to ask the question.
Hi, gentlemen. Thank you very much. Yes, my first question there is what is the fertilizer subsidy? Do you know what it is in India? And yes, secondly, my comment basically on Paul, and thanks once again, Paul, for a wonderful presentation. My comment is that if you enhance the sludge to a fertilizer standard, you start to sell a high value product, and as a result, you are not, or let me put it this way, the transport cost will be carried by the user. And that will even open up overseas markets or export markets for the product. So this is just a comment. Thank you, gentlemen.
Paul, do you want to take that first?
So at the moment, when we sell, we pay the transport costs. Will that change? I'm very interested to watch the Washington, D.C. model, because they are commercially selling their fertilizers. And they are now looking at making it available in depots, and then farmers take it from there. So it will be interesting to watch that. We have not yet looked at the international market. And at the moment in the UK, there's plenty of market for all of our product. But my only so the product that we make available is about 40% dry solids. I would be hesitant about shipping it around the world at that dry solids as to whether it would, I don't know how it would handle. Typically what is transported around the world is much drier than that, but it would be something that could be explored. Go ahead, Sanmit.
Thanks. Francois, I won't come down to the per kilogram, but what India does is caps the pricing of urea. The urea pricing would be probably in the range of $80, $90, $100 a ton, whereas global pricing, of course, fluctuates in anywhere from $500 to $1,000 a ton. And in terms of sort of the DAP side, I would say it's probably a 50 to 60% subsidy given by the government. So the pricing is fairly artificial in terms of what the farmers procure at, and the same is the case with a lot of the oil and gas in the country. Although in recent years, the deregulation of the oil and gas side in terms of market pricing, the pricing has been passed down to the consumers, but fertilizers is a very, very sensitive subject for a lot of the governments. As far as the capital subsidy available to construct the plants, as Mr. Mohan mentioned, it could be anywhere from 15, 20, 30% to even 100% subsidy available to construct the plants. The real problem is the operational costs. So the more we are able to save on the OPEX, the better it is. CapEx is never the problem, in my opinion. It's always the OPEX. And as I mentioned, if the municipalities do not have that capital budget available, then a sludge bond is the right answer, because you amortize the capital cost over 15, 20, even 25 years. And only governments can borrow that for that longer tenor. Commercial players and private contractors cannot borrow for those longer tenors, particularly if there is no revenue model associated with it. So the answer to the question really is in my opening sentence. There is no one size fits all. We have to look at each city, each state in the country, look at what subsidies are available and what budgets are available in different parts of the government, whether central government or state government, and then create a mixed financing model for each city.
Thanks, Sanmit. Any more questions we have? So Paul, I had a question. You talked about sludge centers, and how sludge can be moved to a particular center. Is there a model that says that, this is the maximum or the minimum kilometers for it to be transported, that beyond which it becomes unviable to have a sludge center and it makes more sense to have the sludge treated at site?
So we would always compare it. We would compare the total cost of both options. So if I have a very small site somewhere, my options are limited, but they're probably going to be very CapEx intensive. So I would look at a 20-year whole life cost and look at the option of transporting, and at some point, so if it's very close, transport wins easily. If it's farther away, so the first thing I would do is, rather than transporting liquid, I would start transporting solids. So if it's less than a tanker a day, just keep transporting liquid. Once you get bigger than that, quite quickly it becomes better to transport solids, transport cake. In the UK, in Thames, our guidelines are that we wouldn't build a digestion plant less than 10 ton a day. But I think that is biased by our experience. If I look at, in the Indian subcontinent, you have loads of bagasse plants and small farmers with their small digestion plants. Why can't we do the same municipally? So I think that's more a comment on how we run our plants than it is on absolute technology. But I would always compare, what is it going to cost me to build it and run it versus what is it going to cost me to transport it? And you work out your solutions from there. The other thing we try to work out, so we have a model that has all of our 350 supply plants, our sludge treatment centers, but also our farmers' fields where the final disposal is, so that we don't concentrate all of our treatment in an area where there isn't proximity to farms. So you want to be thinking about that. And as we develop commercialization of gas to grid or gas to transport, then that also influences it. So I may not have wanted to build a sludge center near a transport hub, but if I know that I can put vehicle fuel there, that shifts the economics to where I might consider that. So back to Sunmit's point that you need to look for the formulas that apply to the situations that you have.
Also, Paul, I mean,
One
India,
question.
yeah.
Can I ask one question?
Yeah, Dr. Mehta.
Yeah, Paul, I have a question. In India, there are several plants, numerous plants, I would say, that do not have primary clarifiers. They used, just secondary sludge, including in Bangalore. So this sludge will, as your slide shows, you're getting around 20 to 30% reduction, and does not meet even the Class B criteria for 38% reduction for volatile solids. So for that to, what would you recommend? An advanced anaerobic digestion, or what will be more economical in your view?
So running activated sludge in conventional digest. So mixed sludges, different ballgame.
Yes.
And we have a very few plants that are activated only, but we would transport that sludge to a central location where we mix the sludges, and then we can achieve 45% volatile solids destruction, no problem. But if I had a plant that was only an activated sludge plant, I wouldn't run it with conventional only, because it's very unstable. It's very difficult to run. But with advanced digestion, so with thermal hydrolysis, then that becomes very viable. I still wouldn't recommend it, but it becomes viable. I can achieve 50% VS destruction. I can achieve good gas production. I can achieve dewaterability. But I would always want to work my way up the chain and challenge, is there a reason that I can't have primary settlement? Forget historically what was done. Can I now retrofit that plant? Because my overall cost of treatment. So when I joined Thames, we did black box studies. So we would look at one part of the plant and we would assess that solution. And I said, that's interesting, but it's only part of the picture. Because at the end of the day, I have incoming sewage, I have to have clean water going out, and I have to have fertilizer to farmers' fields. So I need to consider the whole of that process. And when you start asking those questions, you would always put in a primary tank, because your aeration costs are huge compared to everything else. 2/3 of our costs go on aeration. 2/3 of the effluent stream costs go on aeration. And where we're having to do iron dosing for phosphorus, historically we dosed it into the aeration lanes. We've now moved and we're dosing it into the primary tanks, because that gives me more primary. It gives me typically 30% less load onto aeration. That's significant in terms of my whole cost of treatment. And it gives me better sludge to get better digestion, to get more biogas. You need to understand the totality of your costs, not just a small cost. And it will always pay. If you have the footprint, it will always pay to put in a primary tank or primary tanks. And it may even pay to take one of your aeration lanes and turn them into a primary tank, because that's always the better way to treat. Not all of my colleagues will agree with me, but I'm quite passionate about that in trying to understand your overall costs.
One of the reasons the primary clarifiers is avoided is because of the nitrogen limit, and you have to maintain a BOD to nitrogen ratio in your influent of around 4. So if you have a low BOD and nitrogen is high, then they have to do supplemental carbon. So that is one of the key reasons in some places they avoid primary clarifiers, because
So
the cost comes.
yeah, we do have a few places like that, but what I would prefer is to put in a primary tank and then put a controlled dosage of that primary sludge into my aeration lane, because it rarely takes all of the sludge. It might take some of the sludge, but if I'm controlling it, I can give it what it needs, but not what it doesn't need. If I don't have a primary tank, I'm just giving up and letting nature do whatever nature wants to do. It's much smarter to manage the process yourself and only give it what it requires, not everything. But that can be done. It can be done very effectively, where you just dose feed the primary to it. What I wouldn't do, and this is slightly off track, but in England, we tried working with biological nutrient removal, BNR, and BNR always runs short of carbon. And so we tried fermenting primary sludges to create that. But for phosphorus removal, it's a very false economy. For two reasons. One is I absorb the phosphorus out of the effluent stream, but I then put it into digestion where it's all released back to the effluent stream all over again. I also get very poor dewaterability, where 40% of my overall cost of treatment is transport to farmers' fields. So why would I want to make that a bigger cost? But also, we found that when you try to ferment, as the pH drops, the solubility of phosphorus changes, and I end up releasing more phosphorus than the carbon that I'm adding, and it became very counterproductive. So if we're generally moving away from BNR, and if I in total, because it's just not cost effective. But if I do need a carbon source, I would dose carbon without dose primary sludge without fermenting it as my carbon source.
Okay, thank you.
Any more questions that we would have for Paul or for Sanmit? So we have none, I think, that we have, yeah, and no requests for any questions. So I would,
one more question.
Yeah.
To Paul, since he is so experienced. So I was thinking one of the processes could be you put in a primary clarifier and you take out the sludge, and you have anaerobic digestion in two steps, acidogenesis and methanogenesis. And from the acidogenesis, you generate the carbon that you require that can be put back as required into the BNR's thing. So just something I was thinking. So maybe what is your thoughts on that?
So I'll take that in two steps. One, BNR. We have a plant where we can turn BNR on and off. And when I have BNR off, my final dewatering, I use 11 kilos of polymer per ton dry solid, and I get 23% dry solids. When I turn BNR on within a month, my polymer has gone from 11 to 25 kilos per ton, more than doubled in cost. And my transport, my cake has gone from 23 to 17. So I've doubled my transport cost. So I've solved one problem, but I've created a huge other problem. So it is very rare that we find an application where BNR is justified. It can be, but it's very rare. But the other thing I would throw out, and it's, I think it's an extremely good question, is that historically, we viewed the world as, we'd viewed sewage treatment as either I do this, or I do this, or I do this, or I do this. they were choices I had. They were either or choices. What we're beginning to realize is that they are Lego blocks. And I can add the Lego blocks in different ways and in different combinations. So THP is just one more Lego block that I add before digestion, or maybe I add after digestion. I might add digestion in parallel. I might add digestion in series. I might put, I might do my primary and my activated sludge differently. There are lots of combinations, and finding the right combination, we're beginning to explore combinations much more. So in Thames now, particularly in light of carbon and greenhouse gas and impacts on the environment, we're starting to do parallel digestion followed by series digestion, partly because it generates more gas, but partly because we find that we can extract more of the gas beneficially on site and reduce the amount of emissions that will have non-beneficially off site. So we're just starting to explore all of the different ways these Lego blocks can come together. And I think that's very good. I think it's very creative. I think the industry needs that kind of exploring.
One question that has come up in the chat box, I don't know whether it's for Sanmit or for Paul. The question is, how do you see the carbon balance, net zero, and N20 emissions?
Sanmit, do you want to answer that from an India perspective? Because it might be different from a UK perspective, though I'm happy to add in later.
Well, I don't know the answer to from an India perspective. I think India is rapidly rising the curve of net zero, but there's still a long way to go. We have to create a transition economy first, as was suggested by the Prime Minister in Glasgow. 2070 commitment towards net zero, absolutely plausible. Will India get there by 2070? I think my money is India will get there much sooner, but we have to bring all components of the economy together. The one big question we are not answering in India is how do we internalize the environmental costs? I think there's a lot of talk of resource recovery. There's a lot of talk of finding subsidies, but there's hardly any talk of how do we adequately price for water and wastewater. And I think until we answer that question, we won't be able to balance anything. And we have started the process of developing a water market in the country. And we hope to make a lot of progress in the next 5 years. But water and waste, I think, are the two last big segments where pricing, a regulatory form of pricing has to come in. Paul, you would know UK has gate fees and energy certificates and environmental certificates and the price of carbon and lower cost of capital. India has none of those. So unless, in my opinion, unless we start adequately pricing for water and inbuilt into that pricing is cost of wastewater, we will not get there any faster. Although good news is work has started on it already.
Paul, you want to add?
Well, so I think what we also need to do is, and it's been raised already, is a holistic solution to things and realize the interconnectedness of things. So, for example, one of our water treatment plants found they had a problem with nitrites, and it was going to cost them £50 million to put in a treatment plant that could treat the nitrites coming in to make good, clean drinking water. But as we researched it, we found that they were actually coming from our wastewater plant, and it would cost us £2 million to solve the problem in our wastewater treatment plant, that instead of solving the problem in the clean water treatment plant. Now, because it was all within Thames, we could choose to make that decision. It's a different financial group, but we said it was better to invest over here than it was to invest over there. As society, I think it's a bigger question, because as we start to think about the environment and greenhouse and the whole impact, carbon, etc., people are going to say, right, we need to clean up the river. So cleaning up the river, we're going to put more load into your sewage treatment plant. Oh, who's going to pay for that? We're going to say, and it has to be trade-offs. We talked about the trade-off between different types of fertilizer. Now we can provide good, low-cost inorganic fertilizer, non-chemical fertilizers, which is great, organic chemical fertilizers that don't have the same greenhouse. Who's going to value that benefit that we had as a society, as India's commitment to carbon? That will make a huge difference. But how does that get valorized? Society has to ask those questions. And realizing that whole cross network of how things do. The other thing that was quite helpful for us, we actually learned from United Utilities in the north. They were looking at their carbon commitments, and they just sat down and said, okay, if we did nothing else, what would it cost us to meet our Kyoto agreements? And I said, well, we would have to build wind turbines. So what does it cost to build a wind turbine? Not because they intended to build wind turbines, but that became their reference point. And then everything else is compared to that. So internally, we have adopted that policy that says, how are we going to bring our emissions down? How are we going to bring our NO2 emissions down? How are we going to bring our methane fugitive emissions down? And then we compare everything. Well, here's a smarter way to do it. Here's a more effective way to do it. We can do that internally. What we can't do is within the rest of society. And we are inviting, in the UK, we are inviting those conversations with government, with regulators, with the Environment Agency, with energy and carbon commitments. But I think in the UK, you're at a different point in that journey, but you need to be having those conversations as well, because sewage treatment doesn't operate in isolation from everyone else.
Thanks, Paul. So this brings us to the end of the session today. We have had a wonderful discussion. On behalf of the BWSSB team, I would like to thank Sanmit and Paul, for taking time out of their busy schedules and, doing this platform for us. This is a knowledge platform, and, I would encourage the participants to, interact as much as possible with either Paul or Sanmit to get their questions answered going forward. So again, on behalf of BWSSB, I would like to thank Mr. Paul and Sanmit for this wonderful session. And with that, I would like to bring this session to a close. Thank you.
Thank you,
Thank you,
Kailash.
sir. Thank you, sir. Thank you very much.